Hello and welcome to today's webinar, Boosting Reliability, or we could then say availability with ultrasound and vibration. I will be your host today, Christopher Hallam, Operations Manager from North Europe, and joining me today, our guest speaker, James Sylvester, the Director from JPS Reliability. So good afternoon, James.
Afternoon, buddy. Hello, everyone.
So today, just a few housekeeping rules before we start. This is a live event, so if we have any technical issues, please bear with us. It will be recorded and it will be added to our YouTube channel in the coming days. If you have any questions, please stick your questions into the question dialog box. We will endeavour to answer your questions as we go along. If we don't get to all the questions or your question doesn't get answered, we will ensure that we get back to you afterwards over an email to answer your questions. So without further ado, we shall begin. So first of all, for those of you that don't know who I am, my name is Christopher Hallam. I'm the Operations Manager for North Europe at UE Systems. I have a background in electrical engineering and teaching. I've been with UE Systems now for nearly 9 years, teaching ultrasound, supporting users, and discussing general reliability within the field. With me is James, and James, if you'd like to give yourself a little bit of an introduction for the audience.
Hi there. I'm James Sylvester from JPS Reliability. I've been, I started into engineering in a different way than most people do. So I left school at 16. I went to be a machinist, fitter, turner. Did that for 10 years in various types of industry, from chemical to process plants to even automotive. And I was at a plant one day in the year 2000, 24 years ago, when the boss came up with this new fandangle black box vibration thing and wanted someone to put their hand up to give it a go. And I put my hand up and I haven't looked back since. That's 24 years now. So I started from a very practical fixing, coming up with solutions, and sort of went into engineering reliability and done various courses as well.
Excellent. And you've also written some books, James.
Oh, yes. So what I'm quite proud of actually is we've written two books. The first one was called Enhancing System Reliability Through Vibration Technology. That there basically is 20 years of my notebooks I put into a book. So it's like a condition monitoring Bible, like a help Bible. So it's transferring or making vibration talk and reliability into more layman's terms and easy stuff, which I understood myself. In the back of that particular book, I had some case studies. Did that book about 4 years ago, and off the back of that, people were saying how good the case studies were and how it helped them. And then when I started JPS Reliability with my business partner, James Pierce, we decided to make the JPS Reliability Book of Gold. So that is actually co-author of myself and James, and it's over 100 case studies. So it's real life vibration data, stripped down reports, and failures.
Excellent. Perfect, James. And I can say I have the first book as well.
There
So
we go.
thank you very much. Yeah, well, that's you and I, James. So today, like what we said we're going to do with this is talk a bit about ultrasound. I want to introduce UE Systems as well now, so you understand who we are, but who are we representing and where are we coming from? So UE Systems, for those of you that don't know, are global manufacturers of ultrasound technology, providing tools and equipment along with software and training and support globally to users in the field. Be that in industry, be that from a service perspective to service providers. We kind of provide that reach globally. Based originally out of New York, we are here part of the European division based out of the Netherlands, but we have regional offices all over the world with regional partners here, there, and absolutely everywhere, providing support in the local languages and the local dialect. James, a little bit about JPS, please.
Yes. So JPS reliability was started about 4.5 years ago, myself and James Pierce, when we wanted to do things the best way we could and to have full control. We wanted to do our own business. So basically, we've built up on decades of practical experience fixing real life problems using all the condition monitoring technologies. And what we do as a business, we support companies through reliability and maintenance, making sure they do the right maintenance tasks using the right technologies, which in the bottom line keeps production running. So you're hitting your production target. So it protects profit. As for training, as I mentioned, the books, if you see on the picture down there, the picture of the world map, that is actually locations where our books have reached. So we're hands-on mentoring training. We do remote and on-site training. We do global support. So we support service, mentoring, and systems worldwide, and we support quite a few different sites around the world, assisting them with analysis and reliability.
Excellent. Thank you, James. So some of the things that we wanted to cover here, and you'll probably all have seen different renditions of these P to F curves, depending on the technology that someone's trying to sell you maybe, or trying to convince you on. Something we want to talk about here is a lot of people talk about this in the terms of reliability. And as you've just seen from our headline screen about improving the availability of the technology of your assets, making sure that you can have that asset running as and when required and keeping that uptime going. All of these condition monitoring technologies that exist that are out there that can help us identify early defects or early signs of defects is going to help us with increasing our lead time to then make the repairs and whatnot. But reliability is built into the asset, without using root cause analysis and then being able to use that information to then change the design of an asset, we're not going to improve the reliability. So would you agree with that, James?
Yeah, well, one thing I would say from the practical side, this nice PF curve does not exist. It's totally theoretical. What we want to look at is what technology can pick up the defect at a said frequency before failure, because things are so mechanically complex in nature, they're not going to fail as a nice PF curve like that at all. You need to pick the right technology, looking for the right failure modes at the right period of frequency. So this helps people guide, and there's so many different PF curves for different types of failures. So it's a generic to help guide you to do the right thing. But in reality, nothing fails lovely like that. And the bathtub curve is all basically 99% is random failures.
Absolutely. Theoretical. So it's kind of like a sliding chart, you could say, depending on
Yes.
the type of failure mode and the type of asset you're looking at. But again, to understand, we have multiple technologies that are available out there that can help us with guiding us and spotting those early warning signs. So we decided to do this webinar today because we always come across a lot of people that like to have a bit of a fight between the two technologies, one versus the other. And from my experience in the world of reliability, we should never be looking at one versus the other, but actually understanding them properly and understanding how we can apply them as part of a mature, comprehensive program. It shouldn't be ultrasound versus vibration. It should be ultrasound and vibration. How can we use them together to help us get the best data, to help us get the best from our assets and our plants? What do you think, James?
Well, as I say, JPS reliability, we use ultrasound vibration thermal NDT, where it checks the whole toolbox of condition monitoring tools. And on jobs, often we use vibration for and ultrasound together. And it's not that they are different, but wait, later when we get onto the other side, we'll delve more into where vibration does this and where ultrasound does that and how they really work well together. So they're not competing technologies, they're technologies we should be together and choosing the right range or application to use them.
Absolutely. And something we always have to think about as well is that when we're looking at a plant and we're looking at criticality analysis and looking at what can prevent things from happening in production, not everything that fails can be down to something rotating as well. So we have to think about other applications as well, not just one technology for one area. That's where we can use these technologies to help us to our advantage. So first things first, for those of you that maybe are new to ultrasound or have never used it before, what is actually ultrasound? So, as human beings, we can hear in the frequency range of 20 hertz to 20 kilohertz. From the age of about 8 years old, we have our hearing becomes mature and we start to lose the high-end frequencies. So most grown adults can hear between 20 hertz and around 16 to 18 kilohertz. Now, audible sound from its source is omnidirectional in the way that it travels. It penetrates solid objects. It means that when you're trying to locate the source of that audible sound, it can be quite difficult, especially in a noisy plant environment, if you think about all of the different audible noises that are there. Ultrasound is generated at 20 kilohertz and above, way outside of our human hearing range. And when we get into those higher frequencies, the direction of the ultrasound is more directional. It travels more in one direction and is also highly reflective. It doesn't penetrate a solid object. So it means that when we're using an ultrasound device, as we point ourselves at or the location of the source of the ultrasound, we can hear it or detect it. And as we move away from it again, we lose it. So it helps us with identifying the source of that sound. It also means that in a noisy plant environment, an audible noisy plant environment, the ultrasound devices are not monitoring those frequencies. They're not detecting those. So we're picking up just the ultrasound emissions. That ultrasound is generated in two ways. Turbulent flow, so think about a pressurized pipe with a leak, presents turbulence, presents ultrasound, and also friction. So thinking about rotating equipment, the friction in there also generates ultrasound. And ultrasound is highly sensitive, so it means that we can pick up early changes very quickly. With traditional ultrasound devices, what we have is we have a ultrasound device with some headphones, and then we can hear some sound. That doesn't mean that we're actually listening to ultrasound there and then, because our hearing level hasn't changed. We're not superhuman or anything like that. What we've got happening is that there's a process called heterodyning that's taking high frequency ultrasound and changing it. I'm not going to go into the details of that, but bringing it into an audible spectrum that we can hear. And things like leaks and bearings will sound exactly like we'd expect them to hear. So with this, what we do is we can adjust frequencies depending on the applications that we're using it for. And what we do then is listening into that band of frequencies to pick up what we want. So it helps give us that indication of early change in different aspects. So just as an example of the versatility of ultrasound, just to give you an idea of the sort of applications that we can use this for as well. Condition-based lubrication, you think about rotating equipment, all about friction. It's the ultrasound that's being generated. So we can use ultrasound to help guide us on our greasing practices. Tie that in then with looking at condition monitoring of our rotating equipment. We can use it for ultrasonic leak detection, looking at compressed air, compressed gases, vacuum leaks and whatnot. We can also use it then for things like steam trap testing, looking for passing valves, passing steam traps, and looking at the condition of them. And also for electrical inspections, looking at things like arcing, tracking, corona, mechanical looseness, and all of these applications with one tool. So it gives us quite a bit of versatility in the plant environment. One of the quickest ways that we find users that utilize this technology for the quickest wins, the quickest bang for your buck as such, is using the device for leak detection, looking at compressed air and compressed gases. If you look at the cost of energy these days, it's not cheap, and compressed air isn't free. And most plants on average will find that their leak rate is between 30 to 40 to 50% even in places and poorly managed systems. So by being able to use ultrasound to identify leaks and put cost to them, we can get quite quick returns for our investment when starting an ultrasound program. So always something to consider whether you're using ultrasound for certain applications is that leak detection is going to give you your quickest bang for your buck as you use it. So that's ultrasound. James, how about a little bit of an introduction to vibration?
Yeah.
Specialist.
Yeah. So with vibration, people who I've been on site with know can chat and I could chat for hours about this, but very, very simply, vibration analysis can be simple and it can be really complex. There's so many different types of tools, from very basic little pens to detailed analyzers to wireless and online stuff. And sometimes there's a bit of sorcery involved. You need to be a wizard and you see all these squiggly lines and you got to analyze it and tell the customer what's in there. So basically, everything in the world moves. If we have a sensor sensitive enough with cabling and the correct data collector and setup, you can measure the vibration. So vibration is used 99% on everything in the plant for rotating equipment. So if something rotates, it rotates at a certain frequency, and all those components in that motor for say will have a frequency for each component. And we measure those frequencies. And the theory is, and in reality, as assets start to wear and fail, then the frequency would change, either modulate or go up or go down. So by monitoring the frequencies and measuring it, we can detect when there's a change. Now you can do that quite easily, but then you need to understand why there's a change and is it a risk to site. Okay, so on the next slide, what we see here is a little vibration analysis example. This is the simplest one I can find. So we got a spectrum there with harmonics and a bearing defect. So by knowing the speed of the asset, the period of the defect frequency, we can work out it's non-synchronous. And then with knowing the bearings, you put the bearings into the database and you can overlay the fault frequencies. And with vibration, what we start out with, where vibration and ultrasound are quite close now, is the technology advancement. So really high frequency, if you sample above 20 kilohertz, and some kits can sample really high on vibration, we can do then demodulation. So that's the first type, you see it there. Then as you come back into acceleration and velocity. Now this example here highlights the importance of sampling. Vibration is not as easy as some salesman may give it to you and say, press this button, stick it in automatic, let the wizard do it, let it auto build this magic, it'll work for you. Well, you can fail and you can miss things quite badly. And this is an example. So on the one side there, you see a sample rate of 2,560. Now that's your standard 1,000 hertz F max, your ISO. So all these systems online which do the ISO for your wibble wobble, for your fans, they usually got to 1,000 hertz F max. And that's your sample rate. And directly below it is a sample rate to 10,000 hertz F max. And what you can see is this is the same sensor on the 29 RPM shaft, 100 millivolt G, dual rail mount, put on there, measuring, okay? The top one is sampling so slow, it's not seeing the bearing scream for noise. It's screaming, it needs greasing, it's dying. The bottom one, we're sampling faster. So this is where you think we're going to go into ultrasound, because the faster and faster you sample, the higher you go, the sooner you're going to start to see this. On the other side there, we got the spectrums. And what you can see is we sacrifice resolution in the spectrum to give us resolution in the time domain. I think this is probably one of the best examples to show people that it's not as easy to stick it on, press a button and let it go to the cloud, that the little magic robot work all out for you. You really need to understand that you're sampling, looking for the correct defect.
Excellent. Thank you for that, James. Like you say, it's understanding the technology, understanding the limitations, and understanding what you can do. I mean, is this something that's possible with all vibration analyzers to be able to go to these levels?
This is the challenge. With vibration, you can just buy a little meter. We got some with little windows, and it gives you a number. Then you can buy a little pen to measure vibration. When you're starting to spend a lot more money, then you can start sampling higher. So it's a wide world as well. And now we'll talk about MEM sensors and wireless sensors. They are getting better, and technology is advancing so much now. Some MEM sensors are claiming, and we've seen it, they can go to 10 kilohertz sample rate, and even to 13. So it's not all kit does this. So you can't just pick up, like you can pick up an ultrasound kit and listen to something and measure decibel. With vibration, you can't just pick up any vibration kit. You really need to know what kit you've got, not the limitations, but what your kit can do. And when you know what your vibration kit can do, then you can go, right, what other technologies, thermal, oils, ultrasound do you need to add into your picture so you got the full ingredients of like your asset health.
I appreciate that, James. Yeah, absolutely. So it's kind of like not one size fits all as such.
Not at all.
Um,
And yeah, and you can get some vibration systems which give you a nice front face. So you get some nice pie charts, some nice bar charts. But if you don't understand what's going on behind the scenes, how it's collecting data, you could be missing failures and things could be falling over. And then people think vibration analysis is no good. It's not. It's it's perhaps not being communicated what it can actually do and what you've purchased. If that's makes sense.
Absolutely. I think this is probably a pretty good example of where, a user on a plant could deploy both technologies here for these
Yes.
sort
Yeah.
of things, depending on the sort of equipment they actually have. And I think that brings us on quite nicely to one of our first case studies here today. And this is one that I came across out in the field while doing a demonstration, actually. Something that doesn't actually happen very often is finding something as serious as this when you're out there. It's kind of picking in the right time. But this was looking at some trunnion bearings on a kiln. And I was utilizing the Ultra Probe 15,000 with a very simple contact module and setting the frequency to 25 kilohertz and literally listening away to see what we can detect. Now, this asset was extremely large with dual rolling element bearings, rotating at approximately 7 RPM. This asset was only 6 months old as well, so it's very new, very new. But the engineers on site were wanting to make sure that they could use the right sort of equipment to help identify changes early as possible, because if they had unscheduled outages on here, then with this, they'd have big problems. So what we did is we had a little look at each of the bearings that were on this asset. And again, because we had no historical data, we were going to do a comparison method to actually look at each individual bearing just to get some data and get an idea about what's going on. So I took readings at the same point on each of the bearings, and 7 out of the 8 registered 0 decibels. And I could hear a very faint white noise of the bearing, the friction of the bearing in my headphones. So I could still do a sound recording to use it as comparison. And this is what 7 of the 8 actually sounded like. So as you can hear, smooth and uniform, looking at the time waveform there, nothing sticking out, looking really pretty good. Now I came to one of the final bearings on this one, the 8th bearing, and in my headphones, I could hear a very faint ticking sound. And I could see a register of 2 decibels on the screen. Now comparing that to the other 7 at 0, that's quite a rise in comparison when they should all be around 0. Using the software with the Ultra Probe, I was able to then amplify the sound to show the user what was being detected, because my initial concern was that there was damage to the bearing. I wanted to do more analysis first, but my first initial thought was there's damage occurring. We had a member of the team there that had a Mark 1 screwdriver. He placed it to his head and put it on the side of the bearing housing and told me that there was nothing wrong with the bearing. Another gentleman put his finger on top of the bearing housing and said, no, everything seems fine. I can't feel anything. It's absolutely all awesome. They had a very basic vibration data logger, and that wasn't showing anything either. Now, this is the sound I'm going to play you that I could detect in the headphones at a much lower level, I would say, when I was present at the time, but we amplified it on the software. So as we can see, by just doing simple comparisons, all of those bearings were under the same speed and load and same design, same type, and yet 1 of 8 looked very different to the rest and could audibly clearly see that there's a difference there. So eventually the site took my advice. that there was something seriously wrong here. They planned in the maintenance, and a week or so later, I had some pictures sent through to me. As you can see on the screen, as they took the bearing out of the housing, part of the outer race had fallen off. The cage had been damaged and one of the rolling elements had moved 90 degrees. And we could see that in the time waveform as that rolling element slid over the cracks instead of actually rolling over them. It turns out that upon further investigation that this was damage on installation as the kiln was being lowered down and impacting. But as we were just saying before this case study about having the right technology, having the right understanding of capabilities and setting things up correctly, with other types of vibration equipment, there's chances are they may have detected this as well. So again, it's just understanding what you need to do. With the Ultra Probe, I just stuck it on the screen and then listened. But James, you can
I can think of at least 3 high-end vibration kits when, if correctly set up, you can pick up defects, and we've had defects, would you believe it, with a standard dual rail, well, not a standard a quality 100 millivolt G sensor on the dual rail down to like 10 RPM. If you sample correctly and know what you're looking for, you're thinking ultrasound, you can pick it up, but there's only a few kits can do that at the moment.
That's the thing, isn't it, James? It's just kind of, making sure you understand it, isn't it, really?
Yeah.
And, making sure you get the settings correct. And if you have the capability, that's great. But it's also not listening to every sales guy you see and saying they could do this when it might not be able to. So it's all of those getting the right things in the right places, isn't it? So,
yeah, understanding what you're getting.
Absolutely. So yeah, this is one of my favorite case studies. But I think I've had enough of talking for a little while, James. I think we should pass something over to you and give you some stuff, and you just let me know when you want me to move the slides.
So we've got over 100 case studies in the Book of Gold. So I'm just going to go through one quickly. At this particular site, we got a couple of motors and fans, and they're standby duty. So if you look to the next slide, Chris, what we're asked to do is it's noisy. So you go on site, it's a noisy atmosphere, a noisy area. And like with, as Chris has ultrasound, you don't need history to diagnose a defect and put a risk against it. If you know what you're looking at, you understand the machine. So on here, basically, we got 2 sets of data from the 2 separate units. The 2 separate bearings run at the same speed on different units. And you can see the green and the blue. So the green is going plus and negative about 30 Gs, and the blue is 4 G. So straight away, we know what bearing is a noisy one and what's at risk. So that's just overall data of the raw acceleration timeform, and it's always best to start with time waveform analysis. Okay, so on the next slide, what we can see here is we got the raw acceleration data, and we've put it through a black box peak view demodulation type system, and then we come up with this spectrum here. So if you look at the spectrum here, we've got a dominant spike, and if you look at it, it's harmonics. So the distance from the start to the first spike and the next, the distance is the same, so it's harmonics. So you got one signal, a period, pinging, and it's sort of ringing down. Now, the critical thing with any vibration analysis is the speed. If you don't know the speeds, and also, even though we got the bottom here in frequency, if you don't understand orders and get your life in order, without knowing things in orders, the period of a signal, you'll never know where it's synchronous or non-synchronous. So this one here, we knew it is non-synchronous, a period frequency. And then we could say, right, that's either something from outside coming in or it's a bearing signal. And the way we worked this out, if you look at that bearing there, this particular one was an outer race signal we picked up. So if you imagine if an outer race is stationary and you got a mark on it, a damage on an outer race, very basically, if you hold the inner race and turn it, you count how many balls pass that outer race, and that is your BPFO. And this one was at 4.9 orders. Most software now with vibration analysis, all the software, the online stuff, offline, if you know your bearing, you could type it in, it gives you pretty little cursors, but you do not need to know what the bearing is to call it a bearing defect. You got to understand the waveform and the pattern and the data. So on this one here, we then stripped down. On the next slide, just see what we actually found. So First thing we notice when we strip down top left is the grease. If you look at the grease, it's all bitty. So we've either got mixed greases and also contamination coming into the grease. Bottom left is the outer race. And if you look at the marks, outer race is stationary, nothing in the top. In the load zone, we had these lines. Now these lines, if you measure them, were at the pitch of the rolling element, but you can see there's too close. So at some point it's been stationary for such a long time, then perhaps moved a little bit and it's stationary for such a long time. Now this is for spinelling. The giveaway is when you look in the microscope at the bottom of the indents, it's actually rusty because literally the micro movements push the grease out and you get metal to metal contact. Now on the right hand side or your left, you can see the inner race, but the inner race actually has a deeper mark than the outer race, but we were only seeing outer race on our data. So what you got to think when you come to real life situations, you got this big bearing, could be covered in grease, or you clean it off. You're not going to scrape it down, file it, rub it down with emery cloth, put a bit of beeswax to get a good contact. You're doing routine monitoring, you're using a sensor, either a flat or dual rail. And also, if you imagine the bearing there and the bearing spinning around, for that inner race has to be loud enough to pass this or transfer the pore grease through the rolling elements out to the outer race to the outside to measure it on the outer race. So we saw the outer race signal higher. And again, it depends how deep you want to go because inner race, outer race, whatever it matters, the bearing needs changing. So through vibration analysis, you can pick up which is the worst, like ultrasound. But in addition, if you have the equipment, know how to use it, and understand your machine, you can actually sample deeper and pick out what the fault frequency is or what the forcing function is causing the defect. Now that is such a critical process when you want to eliminate the defect from happening again. You can do condition monitoring just with a stethoscope and you can change it out, change it back in, but without understanding what's causing it, you cannot eliminate the defect. I could talk on for ages, but I shall stop now about this case study. Chris.
Oh, thank you, James. No, I think you're right there, though, isn't it? I mean, how many times have you been into a plant where people are using predictive technologies to identify early stage issues, and then do the shutdown and they change the parts, but they don't go any further with it. They then think, great, we've job done, we've detected something, we've stopped it from failing during production, and now it's going again. And then 6 months later, the same thing comes back again.
And that's the biggest miss-sell in condition monitoring when the salesman says, do thermal, do vibration, do ultrasound oils, you'll increase reliability. No, you're not. All you're going to do, you will help process because you will know when things are failing so you can plan it and change it out. But that's nothing to do with reliability and making the machines and the assets last longer.
Absolutely. Root cause analysis, identifying what caused it in the first place, and then finding ways in which you can then mitigate for that and reduce that will actually then in turn help improve the reliability of those assets. So absolutely. Yeah, I think that's a great message for us to get across there. So another big area when it comes to these two technologies is lubrication. It ties handily in with rotating equipment and our bearings. And, you know, it's one of the areas that sometimes it's just so overlooked in some places. I think it's starting to get better in some places, but it's still an area that I think is highly overlooked. And, you know, if we look at premature bearing failures, 80% of premature bearing failures are caused by some form of poor lubrication practice, you know, whether that's contamination, using the wrong type of grease, going long periods of time without greasing, or actually putting too much or not enough in. You know, how many times do you see people have a PM that says 10 shots of grease and then they'll put one in for just for luck, you know, and things like that. It's I mean, James, you must see this, you know, when you're visiting customers on sites and that, you know, the bad practices that are out there. Even
I say the one thing which does shock me, I remember 6 years ago, when I worked at a particular site, we had a power station, and the lubrication guy in the power stations is traditional beefy power station. He wore a white coat, and he was God. He kept that power station running. And what I've seen lately, well, in the last 20 years, is things that people want things cheaper. They make them cheaper. They make them thinner. They don't last as long. They come up with sealed bearings, which are sealed for life of the grease, not the bearing, and all these things, and they push lubrication down, down, down to the bottom where lubrication is the lifeblood. If we're not fixing lubrication, aligning, balancing correctly, then you're on a hiding. Your assets aren't going to last. And using vibration and ultrasound together, you can start picking up misalignment, bearing issues, grease issues, and start eliminating it.
No, absolutely. And I think we could even look at this before people are even considering technologies. Good husbandry, demarcation, cleanliness. How many times do you walk around a plant and actually see covers on grease nipples? It's very few and far
No.
between. I think I can count them on one hand, maybe in my time, the number of sites I've seen with these on. It's having all those things in place because the amount of times that I've seen a company invest in technology to help their lubrication, yet they're going around and picking up a grease gun off the floor to go and grease something, not knowing what's in it. It's not going to help. It's getting the basics right first is equally as important because if you don't have those, then you're onto a losing streak already. So let's move on from our tragedy that is 80% of premature bearing failures being lubrication related. It's all down to friction. If we don't grease our bearings correctly, or we allow contamination to get in, or we have, too much going in, it's going to affect the level of friction in the bearing. And that friction is going to get worse and worse and cause more and more damage to the bearing itself. Now, if we think about traditional, most commonly done time-based lubrication practices, people will go and grease their bearings at a certain interval with a recommended amount. Now, that recommended amount, is that the right amount? Is always the question I ask. And the answer is normally, oh, I don't know. It says it on the PM, so that's what I'm going to do. And so they do that, and then they take a look at the bearing sometimes and think, I don't see any grease coming out of the side, so I better put some more in. Oh, now it's coming out the side. Now I'm happy. Oh dear. So if we think about time-based, is it the right time when they do that? Does the bearing need it actually at that time every single time? So this is where predictive technologies can help us with identifying that changing condition. If we think about it from an ultrasound perspective to start with, is that we're looking at the friction. The friction generates the ultrasound. So we can look for that early change as that friction level starts to increase due to a reduction in lubricant in that rotating asset. So if we could use ultrasound technology to pinpoint that change at its earliest point, we can apply the right amount of grease and use the ultrasound to help guide us to bring it back to its baseline value and reduce that level of friction that could cause damage in the long term. If we go time-based, we're allowing that friction to increase to a level where it eventually will cause damage. Anything to add on that side of it, James?
No, totally agree. Yeah, on time base and motors, the biggest thing I see with motors is people are sometimes afraid to lubricate electric motors because they think the grease is going to fall down and it's going to cause it to blow up. But from all the sites and over the world I've worked, the biggest failure of bearings is mechanical. Very rarely do we actually get a motor that that old that it fails electrically. You do, but it's very rare. 90% plus is mechanical. And you may get a motor that has got a bad bearing defect due to EDM or another defect. So you can go, right, oh, I'm not going to grease it because I'll hurt the windings and your motor lasts 1 month. Or you can do the bad thing and over grease it and your motor lasts a year to the next shut. So it's understanding the options you got and how you're going to help the asset hit the next shutdown and not fail in production and cost the plant money.
Absolutely. Absolutely. So we would give some examples as well about how, what lubrication looks like through ultrasound and through vibration shortly. But if we think about it, and we know people haven't got the time for these sort of things, but the correct way to grease a bearing would to be small amounts at a steady rate while monitoring it as we go along. Now, a lot of people have a lot of things to do, and we have a lot of bearings to grease. So I'm going to show you on this next slide what lubrication looks like ultrasonically. So we can see from this screen the technician there pumping in lots of grease, and the ultrasound level isn't moving yet, but when we start to see grease enter the bearing, the ultrasound level should reduce. And once the level doesn't go any lower, we should stop greasing. But he continues to grease some more. Maybe he was being paid by the shot. So as we can see there, we started at around 58 decibels. And what we should do is grease slow and steady, watching the ultrasound level reduce. Once the ultrasound level doesn't reduce any further, that's the bearing telling us that oh, have I gone through too many here for some reason? There we go. Once it doesn't get any lower, we stop. If we start to over lubricate the bearing, we'll see the value going up. So as we saw there, he probably put about 6 or 7 shots of grease extra into the bearing, and we saw the value go up. So that was an indication of over lubricating. But greasing a bearing with ultrasound can be as simple as monitoring the decibel value. If the bearing needs it, we will see it go down. If the bearing doesn't need it, the value is going to go up, so we stop straight away. That way we can get a better idea of how we grease it. So, James, I'm going to pass the next one over to you.
Yes. So we can this is the video of greasing with vibration. Is it working, Chris?
I'm going to play it now.
There we go. Yeah, there we go. So on this one there, you can see a waveform live and it's sampling. As you grease, the waveform will come and push down. Oh, jump forward.
Something's playing up with my computer at the moment.
No worries. So when you grease a bearing, and you're watching it, your waveform, you can see the waveform. As you grease, you suddenly see the waveform dip and go. And this is what we do on most sites when we're doing vibration analysis, like that. See, it dips and comes down. The benefits of this is when you're looking at a waveform, you can see basically the pattern in the waveform. You can see whether it's got a periodic impact. So straight away you can go, oh, you definitely got a bearing defect. You can grease it we had on some, and it can actually increase because you could be pushing through grease which has been in a 12-inch pipe for a year and it's gone hard and separated. So you're monitoring it, measuring it, and you can see how it's changing. Now, on some sites, if you've got lots of machines, what we would do is you would have like a very simple ultrasound tool because you got to think about your time and utilization of people. So you'd have a very simple solid ultrasound tool to go around on a routine and measure your bearings, your dB level. And if it doesn't change, it doesn't change. You leave it alone. If it goes up, you grease it. And then you have a backup as well, where you have the vibration people hitting your critical assets, and they're looking for early bearing defects. And the main things on most sites is misalignment, balance, and looseness. So you can use a combination. And on some sites where you only have a few machines, you're just doing vibration, then you can do the greasing and vibration at the same time. But the downside is you can't do this with your low end vibration tool you buy. It's usually on the high ender kits where you can see things live and you can up the sample rate really high and you can do some sort of live demodulation reading. So it's knowing exactly when to use what tools when, and that greatly depends on your assets on site, your resources, your skill levels, your failure rates, what you're fixing, what's not going to fail. It's a massive thing to work out what to use first, but you can do greasing very easily with vibration if you know what you're doing.
Excellent. Thank you, James. So with all of this, this is still taking a manual approach. So as we saw from a couple of slides ago, where we see time-based data collecting for helping us identify early diagnosis for lubrication needs, there's still a risk and element there that is human. Us as human elements are the most unreliable things out there. We are the cause of all of our problems. And so, having that ability to monitor that friction level more frequently and being able to be there at the right time when the bearing actually needs it. If we think about our highly critical assets, we could improve the lifespan of our assets even further by taking a different approach And that's, with the advancements in technology, is actually becoming actually more apparent now in this day and age. If we look at it from an ultrasound perspective, things like the on-track system that will actually now monitor the friction 24/7 of the bearing. And then when that friction level gets to its lubrication alarm levels, autonomously applying the right grease at the right time and at the right amount will also help us then improve the lifespan of our bearings. So we have that manual approach of time-based, just putting in what's recommended. We have time-based, condition-based lubrication still there, a bit the ability. Now we have the IoT-enabled autonomous condition-based lubrication that's there 24/7. So technology is advancing, like James was saying about how ultrasound and vibration are merging into different areas now, the similar areas. This is a clear example of how that's actually happening as well.
And with stuff like this, you also got to think of the clients who don't have 20 fans on site, 50 gearbox to warrant getting a consultant in or doing it herself, where they can have remote locations. So when you got a system like this, it can monitor it. And if it thinks it's grease and it's still going up, then you can get a technician and engineer to site to actually investigate why it's causing it and what's changing it. And they're better, they're a big step up from the old auto lubes, because we see many auto lubes. We do routine surveys where people don't put dates on them, and you go back and you go, is that the same one from last year? And there's no grease gone in there. So it really is a good advancement.
No, absolutely, James. Absolutely. By taking this out of the hands of a human, for example, as you can see on this slide here, just seeing a lubrication event that's taken 15 minutes, how many times, how long is it going to take to do a plant lubrication program if you spend 15 minutes per bearing? It
Yeah.
could be there for quite some time. So,
And
absolutely.
there's definitely, again, it does come down to money. It all comes down to money because businesses have got to make money. So all these technologies, wireless, Wi-Fi, online, only use them when it's financially beneficial to the client and to the end user. You could put
Absolutely.
everything on this. You could put every bearing on this. You could put everything on wireless, everything online, and you could spend loads of money and there's no benefit to the company. So you've got to be careful, pick your assets and your applications to use the technologies.
Couldn't agree with you anymore there, James. Absolutely. It's a combination approach. It's understanding the right places to deploy things, and that technology does not replace the Mark One eyeball, your
Yeah.
nose, and your ears. You have to still be able to use those out there. So let's look at the other side of things then when it comes to ultrasound and vibration, and looking at training competencies and looking at what actually is behind that side of things, because these sort of technologies are not things that you're going to just go out, pick up, and expect to be able to go and use it to a high level straight away. It takes time. So, and there's different levels of training. And James, maybe as a person that's written books on these sort of things,
Yeah.
you can go into a bit about this as well.
Yeah. The biggest thing I've seen is ISO training is great. It says people can understand things. It says people can learn. It says they can pass a multiple choice exam and pass it and get a certificate. So they've been trained ISO. That does not mean they're competent. It's a great thing, ISO, because it does help, but you have to bring in competence, because if you don't understand what you're doing, if you just get a really intelligent person to sit the exam, pass it, they got ISO, does not mean they can help you with your system. You got to understand your assets. And in the Book of Gold, we got some pearl of wisdoms, and we often share them on LinkedIn to keep reminding people. But when you do a condition monitoring reliability program, the most important thing is a person you pick has the right attitude, who's doing a data collection analysis. And then it's the training and mentoring. You can have all these salespeople come in, automatic this, automatic that, just do that. Oh, we'll do a free course, it'll all be perfect. And then they go away. They've done a sale and they're gone. You need someone, if you buy something, to have someone you can sound off and feedback on and to learn. And don't forget, if you've been on your plant for 5 years, well, yes, you got 5 years of experience on that plant, but if you've done the same thing each year, it's 1 year's experience 5 times. And always ask, why is it failing? Why is it failing? Simple things. Always try and find out why it's failing.
Absolutely, James. Absolutely. And as you were saying, the certification courses are generic. They will tell you and teach you about the
Body,
principles
yeah.
behind the technology, but there's many different types of equipment in those areas. And the ISO category training courses are going to teach you the technology, but not the actual handheld or the equipment that you could be using. So it's also very important to make sure that you have practical based training, maybe on-site vendor-led training or from support and mentoring from other providers, likes of James Sylvester
Yeah.
at JPS
The, the,
Reliability,
the
that
best way,
mentor people through things.
yeah, the best way we find to support people is no matter if they're buying the most £500 kit to £1,000 to £10,000 kits to £20,000 kits, we always tell them you have to do ISO training, be it ultrasound vibration thermal, not straight away. Use a tool. We do mentoring training for 6 months. So when they do go and do their course, things will click and you'll get so much better out of the training and you'll understand more rather than going in with no experience at all and just trying to learn. If you do pre-mentoring and training, then your ISO course, you'll pass with flying colors because you'll learn so much and get so much more from the course.
Absolutely. I think that leads us on nicely, James, to our next slide, actually, where we talk about the different considerations behind this. And I'm going to have to click through some of these because I didn't realize that we put animations on them.
Mhm.
So we have to think about who's doing what level of work on a site, for example. As James was saying, on-site training, practical-based training on technology is always a good starting point to start building that little bit of experience. Add into there the category courses as well, and going through the different levels, and thinking about who's going to do what, who's collecting data, who's analyzing the data, who's building the reports. And training's great, and training's really, really important. And even once you've, what I would say, become consciously competent at the end of training, it still takes support and mentorship behind you afterwards to then make you unconsciously competent, doing it without thinking. And that's where you want to be. And something that I know at JPS and at UE Systems is something that I'm quite proud of, and see that we can have people out there that are willing to provide that support. Because without that, people will not be successful. But from an external point, it's important, but it's also important to have the support behind you internally. Do you have the leadership of your organization on board with this? Do you have procurement on board with this? Because if you don't have people on board with this, then your program is doomed to fail. It may start and go well for 6 months, but it then feeds off and peters out and goes into the darkness and becomes just another box on a shelf. So having everybody on board with the right strategy is really important, and having that support, mentorship, and regular training too. Wouldn't
Um,
you
um,
agree, James?
yeah. With the support, when you decide when you're going to use thermal oils, lubrication management, ultrasound vibration, always start from the end. Think at the end, what failures you're going to try and find. Then you work yourself back. Then you can work out what technologies, and it will be a combination of you might only need a low end vibration kit and a high end ultrasound kit, or you might want a high end vibration kit and a low end ultrasound kit. But there's different kits to use, and the most critical thing is always keep a record of production downtime and your savings, because what will happen, we've seen it over again and again, production will go up and it's all smooth, it's running smooth, and then suddenly a new manager comes in, oh, what's this reliability department, and then you're gone. So you always keep your wins and production uptime, because in the end the department should be protecting production. You're the reason that they're at 95% efficiency or more, because you're capturing all these things through vibration and ultrasound before they become a failure and affect the product. Because it's all about saving the business money. So remember, condition monitoring, stroke reliability is a profit center. It shouldn't be seen as a cost center. You're protecting production.
Excellent. I am quite wary of the time that we're at as well, James.
Oh,
So I'm gonna,
yeah, sorry.
well, that's okay. No, we could talk all day long,
Yeah.
but I just want to give a quick example of a case study from a user that had not too long, had training and support from UE Systems with some ultrasound equipment. Um, they had done some practical training. They hadn't gone under the ISO category training. It was just a bit of practical on-site training, understanding their assets and listening and learning. And they had a refurbished planetary gearbox come back into service, and they thought they'd start doing some just practice with the ultrasound testing and listening to their assets. So this was a relatively slow speed application, and again, just been refurbished, so should be quite smooth and uniform. When they listened to it, they did a sound recording and sent that sound file over to us because they had concerns that there was something not right. So this is what it sounded like. We can hear quite clearly there the modulating sound as each of the planet gears are coming past the actual sensor itself. But it's a very coarse sound. And that's one of the first questions you ask yourself when using ultrasound is, how does it sound? Does it sound smooth and uniform? Does it sound coarse and crackly? Is it grindy? Is there impacting noises we can hear? But first thing was we could hear this coarse sound that didn't quite sound right to them. So the next step they did was to then bring one of the support engineers from UE Systems in just to have a little listen with them as well and to kind of help guide them. The next step to take was to inspect the oil, look at the oil, because there could be some signs in there that can tell us what's going on as well. Being newly refurbished, when they went to check the oil, it's what they didn't expect. And they found that the oil was black already, which wasn't a good indication. So when they looked at it, it turned out that the wrong type of oil had been filled in the gearbox, which meant that the level of friction was higher than it should have been because of the lack of viscosity. So if left undetected, could have caused more and more damage. What they did was got it cleaned up, got the correct type of oil applied into the gearbox, and then they tested again. And this is what it sounded like with the correct type of oil. So just to emphasize there that this was post training, they'd had some training, they had some understanding, and they found something very quickly. And the change was only just as much as the wrong viscosity of oil that made an increase in friction that then helped them with identifying the issue and moving on, avoiding a failure, but also asking questions of who refurbished that asset as well. So, James, being somebody, out in the world of service and providing mentorship and training and everything else around reliability, how would you talk about the use of ultrasound and vibration in Harmony?
We use them both all the time, from high-end vibration kits, and then we just got a very simple ultrasound tool to listen to the bearings, so we can think vibration ultrasound together, all the way through to high-end cameras and high-end probes. It all comes down to the failure mode: static, electrical, mechanical, process, and you pick the right technology which will pick it up when you need to pick it up. So we have all vibration ultrasound kits within the business, and we utilize them together. And at all the times, even my guys are collecting vibration data, they got ultrasound tool and they're listening to things as well. Because that, when you can hear it and you can see it in the VA data, helps people learn as well and pick up defects better.
Excellent. And also maybe James as well is that for people to, be aware of that, on a plant, it's not always the rotating asset that's going to cause
Oh,
the downtime.
no,
And
no.
understanding things like steam systems,
Yeah.
steam traps, valves, electrical inspections, leak detection, energy savings, there's process leaks that can cause outages and stuff like that too.
Yes.
That's another good example of how they can use these sort of technologies combined.
Oh, definitely. When we do that for a few clients, where you do a whole package where you're capturing the centralized steam systems, you say air leaks, high voltage panels which you can't open. Oh, ultrasound's brilliant. You can put the sensor on the door, use it like a speaker, and you record the sound within the panel which you can't open, and you can pick up. I've picked up mechanical looseness of baffle plates moving at electrical frequency. It's brilliant, and it's a combination of vibration and ultrasound together. You could get nearly all the defects easy.
Absolutely. No, I couldn't agree more, James. Couldn't agree more. Now, we were talking there a bit further, about the integration. I think these slides just kind of re-emphasize what we've just
Yeah.
been saying. If we go back in the early days, of the 60s and 70s and that, where these were just simple analog devices, and how they've evolved into this day and age. And as we were saying earlier, the two technologies are overlapping in
Yeah.
places these days, especially at the higher end of these sort of things.
Yeah.
They do that because they have varying abilities, where you've got vibration equipment that can sample in the ultrasonic spectrum. You've got ultrasound technology now that has built-in vibration. They're all coming into that sort of remit. But again, not everyone can afford the high ends. So it's again
That's it.
understanding how to utilize their tools to the best they can.
It's saving as much money as you can for the business with least costs and picking the right tool from the hundreds on the market. Don't pick the wrong
Absolutely.
one.
Absolutely. So, and that's where, getting independent advice can be very important to make sure that you're not given something or recommended something that
Yeah,
isn't suitable to what you actually
because
need.
you
So,
say you get lots of MEMS online sensors, and everything in vibration has its place. There is a place for the low end stuff. There's a place for the high end stuff. It's when the low end stuff sold as finding bearing defects when it can't. Well, it will when the bearing's fallen over it to pick it up. So it's understanding what your system can give you, get your expectations correctly aligned to what you buy. Then you know how it works.
absolutely. And again, just going into some of the simplicity side of things, again, it's not a one versus the other sort of thing, but we're talking about lots of applications. It kind of emphasizes it, doesn't it, really,
Yeah.
about, use the tools to your advantage and work them together. Don't use them if, one or the other. Use them together. Use them together to get the most from your assets.
I think what people see most of the time, because 90% of everything in a planet's rotating assets, people only think rotating assets, they do vibration, but they do forget it's quicker to check grease with ultrasound. It's easier. They forget the electrical panels can blow up, your steam systems, your air pressures, your bearings, your rollers, your conveyors. So don't just think of that. You got to think of your whole plant, your whole system. And this is where you can use ultrasound and vibration for different failure modes, and they do sort of overlap as well.
Absolutely. And I think it brings us quite nicely onto this next slide, where again we've been talking about ultrasound and vibration, but again, these two technologies are not the only technologies that you
Yeah.
should be considering. There are many different types of technology out there that's going to help us with different applications. Consider the wider plant environment. What are the areas which can cause you a problem? Don't always think about it as just rotating equipment. Think of other areas as well.
Mm.
And again, the technology is not going to be the the savior of all your problems. Think about all of the basics first before you do that investment in technology. Get the basics right. I can see that we've actually gone over an hour,
Oh,
James.
geez.
So we're good at talking like that.
Yeah.
It's one of those things that we can get carried away, but we're passionate people about what we do here. And, you know, I think those key takeaways about people understanding that one technology will not cure all your problems, that's a given. But then with the right equipment for the right applications, you have to have the right training, the right ongoing support to build that knowledge and experience and that confidence. Is there anything else that you want to add, James, before we
Um,
start to wrap
yeah,
up?
one very important thing. Remember, all these technologies do not improve reliability. They will tell you when things are failing. If you then don't work out why they fail, you can't work out why they fail if you don't understand your system. So physics of the machine is so important. If you don't know how things can interact physically in the machine and fail, yeah, you can pick up, oh, it's shaking is going to fail, but it's going to fail and fail and fail. It's a big complex thing. I'm lucky enough to have all these years experience, and that's what we're trying to do, especially with like the Book of Gold, is share the experience and help people learn and realize vibration, ultrasound, thermal, they do all work when they're applied correctly and you understand the machines.
Excellent. Perfect, James. Absolutely. And, keep everyone, keep tuned in the future, because there will be more of these sort of webinars where we'll discuss different technologies and how they can be best deployed and best used with case studies. Um, I appreciate that there's been some questions asked in the dialogue box, and I was hoping that we would have some time at the end to go through some of these. But what we're going to do is at the end of this webinar is we'll have a list of these questions, and we will endeavor to come back to you as well. Keep an eye out for the YouTube channel for when this then gets put up there for you to then watch at your leisure and pass on with your colleagues. Our details are also on the screen. If you have any questions or have any sort of, anything whatsoever, you're more than welcome to get in touch with us anytime. Our websites are always on there as well, so you can look at learning centers and look at advice and tutorials. But what I would, first of all, like to thank you, James. Thank
Brilliant.
you for joining me today with this. It's
It-
always a pleasure having a chat with you about all things reliability
Yeah.
and that. And oh, we can never get bored,
we
can
just
we?
need to make these last about 5 hours so we can talk about it a bit more deeper, especially
Only if,
slow rotating bearings and vibration and ultrasound. But
absolutely.
that's another webinar for that.
Then we'll do another one another day. So, yes, I'd like to thank you all for your time today. I hope you found this useful and enjoyable. And any other questions, please feel free to reach out to us anytime. Thank you very much. And
Thank
thank
you,
you, James.
everyone. Thanks. No worries. Bye bye.